All right, Math 8 students, we are doing lesson 9.4, which is Algebraic Representations of Transformations. So we're taking what we've learned about graphing, translations, reflections, and rotations and applying them to make algebraic rules of how to find the coordinates of our images after transformations. So I'm not a huge fan of the way the book laid this out because it gives you the information on one page and then it gives you the question on the next. So I had a little bit of cut and paste here so that we can see the question and the rules there in example. So you can work through and look at the example. The first thing that we're going to do is find algebraic representations of translations. Now remember that translations are when you slide a figure along a line. So the rules are shown in the table and describe how coordinates change when a figure is translated up, down, left, or right. So if you translate a figure right, you are going to add a to the x coordinate, right? So right, you're going positive on a coordinate grid. So you would be adding the number of units that you move that figure to the right to the x coordinate. For left, you would be subtracting the number of units that you move that figure from the x-coordinate. For moving up, since you're moving positive on the y-axis, you would be adding that number of translated units to your y-coordinate. And when you translate down, you are subtracting that number of units from your y-coordinate because you're moving down the y-axis. So let's take a look here at example 1. Triangle XYZ has the vertices for point X of 0, 0, for point Y of 2 and 3, and for point Z of 4 and negative 1. We need to find the vertices of triangle X prime, Y prime, and Z prime after a translation of 3 units right and 1 unit down. So we are going right. So if we take a look up here at our rules, if we're going right, we are going in a positive direction. So we need to add the number of units that we move to the right to our x-coordinate. In this case, it would be 3 that we're going to add to all of our x-coordinates. So what they did here is they set up a table, right? So they've got all of the points of their triangle. They applied the rules, and then they have their vertices, or the points of the vertices of their new triangle, of their image, okay? So they are just translating to the right and 1 unit down, which means they're going to subtract 1 from their y. So if we take a look at the first point here, which is x, point x is 0 and 0, we're going to add 3 for the movement right and subtract 1 for the movement down. And then you're going to do that to every single point. Add 3, subtract 1, add 3, subtract 1. Once we do that, we have our new vertices. So they went ahead here and graphed the triangle to show that the translation was accurate. And so then you can double check those and see that that is in fact what you're doing here. So what it wants us to do is do the same thing. We're given a rectangle with 4 points. And I'm just gonna, you don't have to, but I'm gonna go ahead and label these points. A, B, C, and D. And then I'm gonna make a table just like they did. So I've got my rectangle A, B, C, D, and then this is going to be my rectangle A prime, B prime, C prime, and D prime. So that's just kind of ordering that for me a little bit. And then I'm going to put my points in here. So I'm going to say this is A, so I've got 0 and negative 2. Then I've got 0 and 3. Then I've got 3 and negative 2, and my final point here is 3 and 3. And I just to stay organized, I just label these A, B, C, D. You didn't have to, but it's just kind of one of those things that helps me out a little bit. So then I'll have A prime, B prime, C prime, and D prime. My new coordinates. Okay. So let's go ahead and see what it is that we are actually doing. We're doing translation, and looks like we are translating 6 units to the left because minus 6 would be moving negatively on the y-axis, right? So if I just draw a little thing here, this is negative, this is positive, this is positive, this is negative, right? This is my x and this is my y. So if I'm moving -6, I'm moving to the left 6, right? So that is left 6 units, okay? And so my rule here would be x minus 6. I don't actually want to close it off yet. And then I am also going y minus 3. Okay? So minus 3 is a translation, would be down the y-axis. So this is down 2 units. Okay, so we've actually described the translation right there. We still need to find the vertices for these points after the translation. So I'm going to take my coordinates and subtract 6 from my x, and then I'm going to subtract 3 from each of my y's. So I'm just going to plug that into my new coordinates here. So I've got 0 minus 6 for my x, and -2 minus 3 for my y. So 0 minus 6 is -6, and -2 minus 3 is -5. So my coordinate for A prime, my translated point, would be -6 and -5. And I'm just going to continue to do this for each of these. So then I've got 0 minus 6 again. That's going to be -6. And 3, right? That's my y. 3 minus 3, which would be 0. So this point would be -6 and 0. I've got 3 minus 6 and -2 minus 3. So 3 minus 6 is -3, and -2 minus 3 is -5. Okay? And then the last one I've got is 3 minus 6 and 3 minus 3. So 3 minus 6, again, is -3, and 3 minus 3 is 0. So these would be my new vertices, and I would need to make sure that I listed those up here if you didn't make a table. So these would be my new vertices. -6 and 5, -6 and 0, -3 and -5, and -3 and 0. So that's using the rules of translation to get the vertices without graphing. So you could always check by plotting your preimage and then doing the translation given and plotting the image and seeing if your points match. So if they don't match, you either made an error in your actual graphing or you made an error in your translations, but it would indicate that you needed to fix something somewhere. Okay, so that is algebraic rules for translations. Let's go ahead and take a look at reflection. So we just did this one. I'm just going to cross this out because we did it already. It's on the previous slide. Don't cross it out because you think you don't have to do it. We did it. But we did it on the previous slide. Like I was saying, I don't like the way that the book has laid these out because it gives you the instructions on one page and the question on the next, so you can't really reference. So I did a little cutting and pasting. So now we're looking at algebraic representations of reflection. So the signs of the coordinate of each figure, when reflected across the x and y axis, will change. The table shows the rules for changing the signs of the coordinates after its reflection. So I'm going to draw my little x and y axis here, just so we've got it. This would be y, and this is positive, y negative. This is x, and this is the positive side. This is x, and it's the negative side. Okay? All right. So if we look at the rules, when you reflect something across the x-axis, you will multiply each coordinate by -1. Sorry, you will multiply the y-coordinate by -1. So when you reflect across x, you multiply y. When you reflect across x, you multiply y by -1. When you reflect across y, you multiply x by negative 1. Okay, so when you reflect across y, you multiply x by negative 1. When you reflect across x, you multiply y by negative 1. Did I say that correctly? Reflect across x, multiply y by negative 1. Reflect across y, multiply x by negative 1. So let's go ahead and use those rules and take a look at the example that they gave us here. So they say a rectangle RSTU has vertices at R of negative 4 and 1, S of negative 1 and 1, T of negative 1 and 3, and U of negative 4 and 3. Find the vertices of the rectangle after a reflection across the y-axis. So that means we're going to be using these rules right here. So first thing they did is they've got all their original vertices. They made a column for the rule, which means that they are going, since they are reflecting across the y-axis, they're going to multiply each x-coordinate by negative 1. So they set that up here. And then they have the vertices of their image. So you can see that they took negative 4, which is their x, multiplied it by negative 1, and that means that their new coordinate is 4 and negative 1. The y-coordinate did not change. Same thing with s. They had negative 1. They multiplied it by negative 1 for their x. So then they have 1 and negative 1. Again, y did not change, x did. Same thing for here for t. Negative 1 times negative 1 for the x. Y does not change. And you have t prime is 1 and negative 3. And the last coordinate there, you have negative 4 multiplied by negative 1. Y does not change. So for u prime, you have 4 and negative 3. And then they went ahead and graphed the preimage and the image and double check their coordinates. So we're going to go ahead and do the your turn now and take triangle ABCD with its vertices. I'm going to set up the table like last time, because this helps me make sure I'm following all my rules. So I've got triangle ABC, and this will be triangle A prime, B prime, C prime. And I'm going to find the vertices of the triangle after a reflection across the x-axis. So with my x-axis, that's this rule right here. For the x-axis, I'm going to multiply each y-coordinate by negative 1. So that means that I'm going to take, for my rule, x is going to stay the same. Y is going to be multiplied by negative 1. That's a little multiplication dot there. So let's go ahead and fill these points in. A, negative 2 and 6. B, is 0 and 5. Sorry. C is 3 and negative 1. Okay, now I'm going to apply the rule. So when I apply this rule, I need to make sure that I know that x is not going to change. Y is going to be multiplied by negative 1. So this is reflected across the x-axis. X stays the same. Y is the one that changes. So negative 2, nothing happens there. And then I've got 6 times negative 1. So I've got negative 2. Well, let's make sure we got correct notation. A prime, negative 2, and 6 times negative 1 is negative 6. So that's my new coordinate there for A prime. For B, my x coordinate will not change, so it stays 0. Then I've got my y coordinate of 5 times negative 1. So 0 for my x, 5 times negative 1 is negative 5. For my C coordinate, point C, I've got x that does not change, and then I've got negative 1 times negative 1. Y of negative 1 times negative 1, that's our rule. So my coordinate for C prime, my coordinate for C prime would be 3 and negative 1 times negative 1, which is positive 1. So these are the new coordinates of the vertices for triangle A prime, B prime, C prime. I'm just going to fill these in up here. A prime is negative 2 and negative 6. B prime is 0 and -5. And C prime is 3 and 1. And so those are the coordinates for my triangle ABC after it's been reflected across the x-axis. So make sure you've got these rules here. Okay, so the last one that we're looking at, and we just did this on the previous page, right, is algebraic representations of rotations. So we're going to go ahead and when we're using points that are rotated around the origin, so this is assuming that our center of rotation is the origin. So that's how you have to use this rule. The coordinates of the image can be found using the rules in the table. So if you have a 90-degree clockwise rotation around the origin, you're going to multiply each x coordinate by -1, and then switch the x and y. For a 90-degree counterclockwise rotation, you're going to multiply the y coordinate by -1, and then switch x and y. And for 180, you will multiply both by -1. No switching. So they give us an example here, and it's telling us quadrilateral ABCD has vertices at A of -4 and 2, B of -3 and 4, and C of 2 and 3, and D of 0, 0. Find the vertices of quadrilateral A prime, B prime, C prime, D prime after a 90 degrees clockwise rotation. So that would be this rule right here, 90 degrees clockwise rotation. And then graph the quadrilateral and its image. Okay, so they have set up the table where we've got the vertices of our pre-image. And then we've got the rule, which in this case is multiplying each x coordinate by -1 and then switching the x and y, right? So it would, what they've set up here is that they switch the x and y, and then x is going to be negative, right? Multiply by -1. So it would be the opposite of what you have. And then they've got the vertices of the image set up here. So the first thing they did is they switched their x and y, and they multiplied that by -1. So then their new coordinate was 2 and 4. In B, they've got their original coordinates. They swapped x and y and multiplied x by -1. On C, they swapped their x and y and then multiplied that x coordinate, original x coordinate, by -1. And then for D, they did the same thing. Well, those are 0, 0s, but that doesn't change anything, right? So those are going to be the same. And then they went ahead and graphed them and double-checked their vertices to make sure that they did things accurately. Okay, so I'm going to take a look at my your turn here. And I'm going to skip reflect for now. We'll come back to that. I want to jump to your turn first. And we have a triangle with vertices, J of -2 and 4, K of 1 and 5, and L of 2 and 2. And we want to find the coordinates of the vertices of the image after the triangle is rotated 90 degrees counterclockwise. Okay, so I'm going to jump over here and find my rule for 90 degrees counterclockwise, and that is this one right here. And for that rule, I'm going to multiply each y coordinate by -1, and then switch my x and y coordinate. So I've got my original, and then this is the rule. I have a -y and x switched. So I'm going to set up my table. Oh, and just a quick reminder, guys, just for a visual here. Clockwise, counterclockwise. All right, and setting up my little table. Let's try that again. So I've got my triangle, J, K, L, my rule, which is x, and y is my original, and that is going to be, I'm going to multiply my y coordinate by -1, and then I'm going to switch them. So I'm going to end up with -y and x. And then this will be triangle J prime, K prime, L prime. So I'm going to write my coordinates down in here. For J, my original is negative 2 and 4. Negative 2 and negative 4, excuse me. K is 1 and 5. L is 2 and 2. Okay, so then I'm going to go ahead and apply my rules to each of these. So I need to multiply my y-coordinate by negative 1, and I need to switch them. So I'm going to go ahead and do negative 1 times negative 4, because I switched them, and then negative 2. So this was my original y, right? So I switched these, and then I'm multiplying this, my y-coordinate, by negative 1. Okay? So negative 1 times negative 4 is positive 4, and then the x, which is now the y, is 2. Oops, and this should be j prime. Okay, so same thing here. I'm going to switch them, and I'm going to multiply that original y by negative 1. So negative 1 times 5 and 1. So k prime is negative 1 times 5, which is negative 5, and then 1. And I'm going to do L prime. So I'm going to switch them. So I've got negative 1 times 2 and 2. So then my L prime, negative 1 times 2 is negative 2 and 2. Okay, so my new coordinates are j prime, 4 and negative 2. Oh, there should be, I forgot that negative. 4 and negative 2. K prime is negative 5 and 1. And L prime is negative 2 and 2. All right, so I'll just write those in here. J prime, 4 and negative 2. K prime, negative 5 and 1. L prime, negative 2 and 2. Okay, now we're going to jump back to that reflect question. So, communicating mathematical ideas. How would you find the vertices of an image of a figure rotated 270 degrees clockwise? So, a 270 degree clockwise rotation, so if I'm looking at this here, I got my little coordinate, and let's say I'm starting right here. That's my original. And I'm going 270 degrees clockwise. This would be 90, right? This would be 180, and this would be 270. This is the same as a 90 degrees counterclockwise rotation. So I can use the same rule for a counterclockwise rotation of 90 degrees. And so I'm going to write a 270 degree clockwise rotation would produce the same result, or is the same as, a 90 degree counterclockwise rotation. Okay, so the rule that I would use then would be for a 90 degree counterclockwise rotation, in which case that's the rule that we just used. You would change the sign of the y-coordinate and then switch x and y. And that's what we did by multiplying by negative 1. We changed the sign of the y. Then switch x and y. So you got to kind of make some higher order thinking connections there for that. Now you could have said, okay, and it would produce the same result. You could have said, well, you could do a 90 degree clockwise rotation plus the rules of a 180 degree clockwise rotation. You could do that, and that's not wrong. But you could also just do one less step and do the 90 degree counterclockwise rotation, right? So connecting big ideas there as we go through. All right, so we will do the guided practice together in class tomorrow. If you have questions as we went through this, please make sure you write them down. It's a lot of memorizing rules, and I don't expect you guys to have these rules memorized. So be prepared to have them for reference and know that you're going to need them. And that's okay. That is okay to have these for reference. That's all I've got for you guys on lesson 9.4. I will see you on the flip side.